Hi there, my name is Marcos, and I'm going to show you a quick demo of our project for the Docker Hackathon 2016. So we made a project that allows us to use Docker DApp files as swarm service blueprints. But what does it mean? Let me show you first what Docker allows to do with DApp files as it is today. So if you can see my terminal, I have two panes. On the left pane, we're going to assume that I'm a developer, and on the right pane, we're going to assume that I'm an ops guy. So if we go to the left pane, we're going to see that we have two compose files. Both compose files are from an application which is from the same domain, but each of the compose files describe different services. So if we look at the first compose file, we're going to see that we have a worker service, a DB, and a result service. And if we look at the vote file, we're going to see that we have a vote service and a Redis service. Now we're going to use the latest Docker Compose version to actually generate the DApp file from the vote.yaml file. So I'm going to use the bundle command, and I'm going to specify that I want the vote.dab file. So this is going to generate a DApp file that now moving to the ops person, I'm going to use to deploy. So I'm going to remove this unnecessary file. And now I'm going to use the docker stack deploy command, and I need to specify stack name. And as you can see, this is how it works today. So I have my stack deployed, and if I do a docker service ls, I can see that docker service ls, I can see that my services are running and are actually deployed. Another important thing to mention is that if I need to find out which port my service is exposing, I need to do a docker service inspect, and I need to specify the name of the service, and I need to look into this big JSON to actually see that my service is listening on this random port that Swarm uses. So if I go into my browser and I try to browse the address that the Swarm is using, I should see that my application is running in the local Swarm mode. There you go. So as you can see, the application is running. But let's say now, moving back to the dev role, that I need to modify my application, and therefore I will have to modify my DApp file, and I need to specify a command, which is something new that the application is going to have, and I accidentally put something incorrect here. So we're going to put something. So what this is going to do, this is going to basically break the application because it's an incorrect launching command. So the normal workflow would be that I generate this DApp file and I give it away to the ops person. And the ops person, the only thing that he can do is to use the docker stack command. And the only command that he can apply to that DApp file is deploy. So he's going to do docker stack deploy again, and it's going to update the stack with the new DApp file that I just generated. And he's going to think that everything went okay because he can't actually see anything of what's happening with the update. But suddenly he's going to realize, if he does a docker service ls, that one of the services is not running because the user made a mistake and gave him a really bad dump file. Okay, so we have seen this issue, and what did we do for the Docker Hackathon? So basically, what we did for the Docker Hackathon is a tool which is called Whaleprint that allows you to manage these DApp files as Docker Swarm blueprints. You can go to the web page, which is the GitHub repo, and you're going to see that the idea behind it is that allows you to handle Docker DApp files as descriptive files to show you exactly what is it going to happen if you want to apply changes to your current Swarm services. So moving back to the first example, so we have our DApp file. So let's say that the developer goes again and fixes that mistake that he made before. So he's going to remove this, for example. He's going to save it, and he's going to handle it again to the ops person. But this time the ops person has Whaleprint, which is a tool that he downloaded, which is 100% compatible with Docker and with the current DApp format. So he doesn't need to do anything at all to use Whaleprint. He just needs to have the binary in his path. And what he can do is do a Whaleprint plan. So what Whaleprint plan do is it will show an execution plan that what is it exactly going to happen whenever he wants to update any of the services of the DApp file into the Swarm. It will actually query the Swarm, it will compare the local services with the remote services, and it will tell you exactly what's going to change. So if we take this case, we're going to see that the command is changing from something that it is incorrect to nothing, right? Which is the same configuration that the service has had at the beginning. So once I know that I have this change, I can go ahead and do Whaleprint apply, and Whaleprint apply, and you're going to see that the Whaleprint is going to apply the service correctly to my Swarm services. And if I do a Docker service ls again, I'm going to see that both services are running. But what else does Whaleprint offers? Well, Whaleprint has a lot more features, and I'm going to describe the most important ones. So what I can do is we have extended the DAB format, and we added some fields which are not included in the current Docker DAB specification, but we thought that they are really useful when trying to use this file as something that you are going to share between environments and teams. So we also added the replicas parameter, which is something that you can specify here, and that Whaleprint is going to take into consideration. And another important thing is that Whaleprint can handle multiple DAB files at the same time. So what I'm going to do here is I'm going to generate another DAB file from the result YAML file. So I'm going to use the bundle command again, and I'm going to output to results.dab. So now I have two DAB files from the same domain application, but those DAB files have different stacks, right? So with Docker, I now have a way of applying multiple DABs in one operation with knowing exactly what is it going to do. But Whaleprint, if I go to the ops role again, I can do Whaleprint plan again, and what you're going to see is that Whaleprint is going to tell me, okay, you're going to add two new services, which are the result services here, and you're going to add three services, which is the worker, the result, and the DB, and you're also going to modify the Redis with the replicas parameter that we just changed in the current DAB. So if I agree with this plan, I can just go ahead and do Whaleprint apply. But before doing that, I would also like to show you something, another cool feature, which is you can tell Whaleprint to print a plan for only a stack. So I'm going to tell Whaleprint, okay, just print me a plan for the stack vote, or print me the plan for the stack result. So you can customize, you can be very declarative in terms of what should be done instead of how it should be done, which is what Docker does today. And this follows a logic, right? You can see the desired result that you're going to have, and it's a proof of statement that you're doing declarative services versus imperative services. So now that I have my plan, and I do want to apply all these changes, so if I hit a plan again, I can see everything. I can do one more thing, actually, that is pretty nice. I can use the target feature, which is something that instead of applying whole stacks, I can tell Whaleprint only process this service of this stack, right? So you can also apply changes to service atomically instead of applying changes to the whole stack or to multiple stacks at the same time. But as I agree with this plan, and I believe this is going to do the correct thing, I'm going to go ahead and do Whaleprint apply. And you're going to see that Whaleprint is going to apply. It's going to create the new services which weren't on the Swarm before, and it's going to update those services that have modifications. If we take a look at our services now, using the Docker services service ls command, you're going to see that all our services are created, and the vote ready service, which is the one that we specified the replicas for, has currently two replicas, which are the ones that we specified in the DAB file. The DAB file can be extended with a lot more features. We added support for public ports, replicas. You can set constraints. You can set a lot more things. So I invite you to look at the repo and see all the other stuff that we support. Now, if I run Whaleprint plan again, you're going to see that Whaleprint won't print anything because there's nothing to change. But if I still want to see the detail of my Swarm services, I can use the -- detail, as you can see here, and Whaleprint is going to print everything that it is currently in my Swarm. And I can also use the other flags Like for instance, I want to see a specific stack, which is vote. It's going to print only vote, or I want to see only just one service. So with the target flag, you can see only one service. So this is pretty cool. But one last thing that I would like to show you is, remember at the beginning when I told you that when a new service is created, you need to query the swarm to look for the ports that it's exposing? Well, we also added a feature for that. So if you look at the Whaleprint help, you're going to see that Whaleprint has an output command. So if you do Whaleprint output, Whaleprint will help you to see which ports are published by each of the different services. So I can see, for example, that my result service, that it is a new service, it's exposing something in this port. So if I go to my browser and I hit that URL, you're going to see that this one actually, you're going to see that Whaleprint is actually helping me to see which ports the swarm selected when publishing my services. Whaleprint has a lot more features which are really cool, but these are the most important ones. So I invite you to go into the repo, which is github.com/mantica/Whaleprint, and you'll see all the stuff that you can do with it. And we hope that you enjoy it, and it helps you with your provisioning and service definitions for your production environments. Thank you very much.